Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. We have a really great guest today. Michael Johansson from Anemo Analytics is going to be joining us. And Alan, what were some of your takeaways from our call with Mr. Johansson?
Well, Michael has a series of really great innovations and technology on monitoring of wind turbines and then using that data to do some predictive analysis and also determine where wind turbines are not operating at their peak efficiency, which is a very unique set of skills that in today's world is really becoming more and more valuable as we try to drive the efficiency of wind turbines towards their optimum. It's going to take the knowledge base that Michael has and his company has to push everybody forward. So this is a really fascinating technical and sort of business-related discussion.
Yeah, and it was interesting to hear him talk about going from a longtime Siemens employee and finally, taking that leap of faith and going out on his own and starting his own company, and now how he works alongside some of these really big companies in a very complementary way, which is interesting because, as you and I have discussed, sometimes the big companies just want to snuff out the small ones, right? But he's found a really interesting way of just working alongside them and helping to sometimes internally train their employees, and it seems like he's married what he does really well at his company with a lot of what these bigger companies do.
Yeah, his skill set is really unique. That it's one of those skill sets that maybe a larger company wouldn't want to have on hand, just because he's deep diving into data, a lot of data, and then doing basically predictive analysis of where energy is leaking from. So obviously working at a large wind turbine manufacturer, you get play with all the toys and all the cool stuff, but it also kind of ties you into having a 9-to-5 kind of job where you have to be there Monday through Friday, and you don't necessarily have some of the freedom you have of running your own company and sort of doing your own thing. And Michael's taken that initiative and moved on to his own business. And it's very similar to ours from the sounds of it. And the really key point I pull out of all that is for his company to be able to offer his resources to the world and to work for a variety of different wind turbine manufacturers and wind turbine operators and provide his knowledge set to a lot of different places, because that's what it's going to take to make the wind turbine industry its maximum production. It's going to take a lot of good ideas from a lot of different places, working very hard to make wind as profitable as we know it can be.
Yeah, so without further ado, we're going to take you to our interview with Michael Johansson of Anemo Analytics. I want to talk kind of circle back and talk a little bit about your business and why you started your company. So you have had a ton of experience working for Siemens Gamesa, and at some point you decided that, hey, I think and I want to do this on my own. Can you tell us about your experience in the wind industry prior to starting your company and why you decided to go out on your own?
Yeah, I guess I started in the wind industry in 2006, where everything was taking off, in particular offshore. In Siemens, and not really knowing a lot. I came out of physics worlds, doing telecommunication and optics. So somehow a world of the smaller the better, and then suddenly turning into the wind turbine industry, where it was the bigger the better. So I didn't know a thing, right? I could just do my math and my physics, and I could spell rather good, and I could do the discussions, but kind of getting through all kinds of different issues. Warranty cases, prototype turbines, commissioning. Went a few weeks to Scotland to do commissioning of turbines. Spent a few years in Shanghai setting up an engineering department for Asia Pacific. So kind of just knowing the technology from inside out, doing all kinds of weird things. So it was a fantastic ride. It's a great company. I love the technology and I love all the good people working there. But I think just at a point in time, I somehow got stuck as an engineer. I wanted to go back and do something, somehow as a key engineering guy. and I kind of left that behind. I didn't have time for it in corporate. So 4.5-5 years back, I teamed up with an old buddy of mine who has done quantum physics, and he I can do my math, but he can do it like to the perfection. So I could basically, having seen the industry, supporting sales jobs in Siemens, project execution in Siemens, and fantastic projects, fantastic technology, but kind of knowing where the issues were if you're on the asset owner side, and then basically we could build up a team where they could do the math, supporting asset owners today in somehow getting a independent fact-based view into their actual operation of turbines based on the data they already have. We don't mount anything on the turbines. We don't add anything into the complexity. It's complex enough already, but just leveraging what they already have.
And so, was that a big leap of faith? I mean, it's always scary going out on your own, leaving your salary and a consistent paycheck, and the support and resources of such a big company like Siemens. I mean, what were some of your trepidations about? Oh man, are we really going to do this and go out on our own? I'm sure that was a big leap.
Yeah, it was. I've been through kind of a similar journey in another industry before that, from 2000 to 2005-6. So, but of course, I was way younger back then, so the risk was not that high. I guess when I left Siemens, I was with kids and family and house and dog and whatever. So of course the gamble was a bit different, but I think end of the day it's mainly a mental game. Just look at today, right, with all the COVID stuff hitting all of us. What is really the safety in a job anyway? So
Right.
So if you can get across that mental barrier, right, and you kind of give yourself whatever 3, 6, 9 months to step out and do something, you can always go back and get a job with a nice company again.
Oh, sure.
So I think it's mainly a mental thing. It can be a big barrier, but it's not really a barrier.
Yeah, that's a good point. Absolutely.
Yeah, and I think there's just a step in time, and I went through the same process, Michael, and I think you're hitting a lot of points that I went through, which is you work for a large company, you get to see all the neat technology and all the toys, but at some level you don't get to play with all the toys because you can't. It's such a large organization; they need to be moving in a certain direction, and they don't necessarily want to move in the direction that you want to move, or maybe that is as mentally challenging as you would like it to be. And that's where a lot of scientists, engineers finally make the break, is that they see this opportunity that the larger company can't address or won't address because of their size. And it's a challenge. It's a challenge like no other challenge to go out and to prove to the world that there is this missing piece that needs to be addressed, and you can actually make a significant impact. And you have. I mean, you clearly have. You're making a significant impact on the performance of wind turbines, which is really changing the world. So in a very small sense, your company is changing the world in ways that maybe you couldn't have done it at a larger company. And I think there's a lot to be said for that. And I think you addressed the COVID thing quite nicely, that in the era of COVID, having flexibility is really good. And you can always go back to work for a large company because you have that skill set. But it is fascinating to us to watch a lot of the smaller companies excel during COVID. And I'd like to hear what your experience has been over the last 10, 12 months, how your company has progressed to this COVID phase.
Yeah, it's of course in Denmark it was mid-March that the country was closed down the first time, and then it's been a bit on and off since then. So of course, right when it happened, you don't really know what's going to happen. But I think we soon realized that we weren't being impacted at all. I think we're somehow lucky to be in an industry, and especially working with turbines in operation, where you can say, COVID or not, turbines keep spinning, budgets have been placed, right. It needs to be maintained.
Right.
So we definitely saw actually a positive thing, that a lot of our customers having a really busy day, keeping the turbine spinning. They had more times because they're sitting at home, maybe not having all the overhead of corporate meetings. So we had some good technical dialogues. and we progressed quite a bit on a number of North American sites. So it's been a good 2020, but also basically as planned. So I think we've done reasonably well, but that's somehow also how we planned on it when we started in US 2.5 years ago.
Mm-hmm. Yeah, you raise a very good point that when engineers actually have more free time, they start to think about the more complex problems. And when in a corporate environment, it's very hard to do that if you have paperwork to fill out and forms to fill out, and you have corporate meetings that always last an hour, no matter what you do. And then all of a sudden, you take those engineers out of that situation, and they're able to have, one, some quiet time, and two, the time to think. Then they're reaching back out to you saying, "Hey, I think we have these issues on our site, and we need to be addressing them. And now's a good time. I have some free time to think about it." They're reaching out and asking for help. And I think that's brilliant, because this is the time that really, especially for the wind turbine side, where investment back into your facility is the right thing to do, because you have available people, you have available time. There's like you said, no corporate overstructure slowing you down right now, so you can go as fast as you want to. Have you seen that sort of influx of new customers or inquiries coming from particular places in the world? Is it mostly United States? Is it mostly Europe? Is it South America? Where are your customers typically based at?
Yeah. So if we start with the later part first, so we started up as a company in Denmark, right? And with our a lot of us has a background in Siemens, and some of us also work with Ørsted in offshore. So of course, rather dominated by Siemens turbines, and that's dominating particularly onshore Europe and offshore Europe. So that's where we spent our first few years. And then when we started in US 2.5 years ago, there's more and more questions coming in on the GE turbines. So core business right now is Europe on and offshore, and North America. And North America is rather multi-branded. And then whether it has moved faster or not for the past year under COVID, you never really know what you would have received if it wasn't for COVID. So whether it's faster or slower, I don't know. It's a tough call as a smaller company like ours, right? Just because customers coming in wouldn't have come anyway. I don't know.
Right. Well, it's said like a true engineer. You have nothing to compare it to. So
sorry for that.
No, that's exactly right. That's a great answer, because it puts its sense into your mind frame, in your mindset of, hey, we're in the business of comparing data. I don't have data, so I can't compare them, right? Because that's what your business is. Really, your business is really comparing data, right? Yeah, sure.
But if I may spin back, then may I link two other topics we discussed then. So rotor and balance, right? And COVID. So one of the discussions that at least has been new for the past year, and you can say one of the value propositions that we wouldn't have if it wasn't for COVID. Then the whole thing that we on the remote can sit on a portfolio of whatever, 5-10 sites, or how many sites the fleet manager is operating, pull out the data and then assess all turbines, individual blades, what is the pitch measurement on that blade, on that turbine, on that site, on that tower. Of course, that has always been a value proposition from our side. But now, of course, it's an additional value from our customers that now they can sit on remote, right? Either in winter time or in COVID time, sitting from back home, and kind of they don't need to visit the turbines. So also the value added of cutting down visits, technicians spending time in a different way on more pressing matters, has maybe been accelerated a bit here under COVID.
I definitely think so. I think that's been the case. And have you seen much difference in the amount of I don't want to say business, but I mean just the questions coming from onshore turbines or offshore turbines? Is it roughly the same? Since you're dealing with both styles of turbines, have those markets really changed in the type of, because they're different businesses. There's the complexities of each one of those is different. Are you seeing more offshore questions now than onshore? How does that break up?
Yeah, I guess just as well as the onshore market is with different clients. I think our experience is that a lot of the offshore clients out of Europe, they also comes in various maturity levels within this domain. Some are really up there running a big portfolio and can do a really good job and really leveraging their scalability in the business. It's really impressive. Sure. Where others are on that journey and they have bits and pieces of it already and are now going in the same direction. It's also about knowing those specific customers, right? Just as I said on the onshore market in the US, with the diversity you have there between clients.
Well, there are different types of problems from offshore to onshore. Can you highlight just what those differences, what you typically see? Like these offshore turbines are going to have this type of problem, corrosion, whatever, versus the onshore ones, which are more about imbalances, yaw. What are the differences between the two in terms of performance that you seem to highlight?
Yeah, you can say, of course, there's a big difference between the business running an offshore wind farm and onshore, and in particular in the cost structures. Offshore, you have the vessels that are driving vessels and the logistics driving everything, right? So value-wise on an onshore, you can multiply that by 3, 5, 10. So of course, the impact you could do on an offshore wind farm is significantly higher. But if you turn the question around, end of the day, a lot of the turbine individual issues, part control issues, they're the same. It's just a lot more accelerated offshore because wind speeds are higher, loads are higher, fatigue loads are coming in sooner. But end of the day, the issues are the same because it's just a turbine, right? But the cost structure might be different and the value proposition might be different. And of course, then also bear in mind, at least from a lot of the topics we're dealing with, which is in particular within load and dynamics control and software on the turbines and on the pack pilots. You know, the controllers on the turbines are the same, whether the turbine's onshore or offshore. Right. So some of the flaws and opportunities for improvements, you know, a certain OEM turbine onshore is the same software piece that is sitting offshore, just configured a little bit differently. Mm-hmm. But fundamentally, it leaves room for the same improvements. And then value impact wise, you can multiply that by 10 or whatever offshore, right?
So the offshore, the much rougher, harsher environment with the bigger turbines, is that what problems does that tend to accelerate that you've seen? Do you see things get out of balance faster, out of alignment faster? What's been your experience there? So from physics and engineering, it's the same thing, right? But the impact might be more severe and failure rates accelerating faster. But of course, it's also a bit of a difficult comparison, if I may be the engineer again, because a lot of the work that is done on the onshore machines, being 5, 6, 7, 10 years old, is not really comparable to a 2, 3, 5-year-old offshore wind farm. So it's also comparing a bit apples and bananas, because end of the day, the mechanical components are the same. If we disregard corrosion, if we disregard all the third-party components the need for aviation or whatever offshore, right? If you look at the core fundamentals of a turbine, it is the same turbine.
Mm-hmm. It is, yeah.
So a lot of the onshore experiences within loads, aerodynamics control, the methodologies, the capabilities, the competences, it's the same. Of course, logistics is a completely different game. But the core fundamentals of how does a turbine operate? What are the failure modes? How can I look for failure modes? How do I troubleshoot? It's the same. It's a harsh environment, but the failure modes are the same.
Well, and so that's an interesting point. We talked with Bjorn Hedges, and he talked about how it does take a good amount of time to really understand a given turbine. So you might have a technician who's an expert with Siemens, you might have another technician who's an expert with GE, and for either of them to get up to speed with the other brand of wind turbine, it might take them a good amount of, a handful of years to really understand the inner workings. Mm-hmm. And obviously you had tons of experience with Siemens turbines. Do you see much of a difference with, hey, we've got a brand new, like we talked about GE's new Cypress onshore wind turbine recently. I mean, does it take you any amount of time to get up to speed when there's a new model, a new brand, or a new style?
Yeah, it does. It does. It is not, you can say, the core fundamentals are the same, but with the detail, we look into performance optimization. The details are different. So to just take the example we had from before, right? Single pitch misalignment, I have mentioned a few times. It's a concept that's rather easy to understand, whether it's whether a rotor imbalance in general, right? Whether it's a mass imbalance or a single pitch misalignment, it's a well-known issue. But how does that work on a Vestas turbine or a GE turbine running individual pitch control? Inherently there shouldn't be any, right? So the whole definition of that topic kind of vanish. So you need to think of it a bit differently because the control structure of that turbine is different as compared to a turbine running more traditional pitch control.
And can we go a little bit deeper into blade mass imbalances? So how do you diagnose them, and then what's the actual fix? Because I know obviously everyone here is familiar with cars, right? You get new wheels or you get new tires, and they have to go balance them, right? You have those little lead weights that you stick on, but I assume they're not sticking any lead weights out onto a 100-meter wind turbine blade. So can you walk us through that process and explain kind of start to finish, like how do you diagnose and then actually solve that problem?
I think our general experience is, first of all, it's a standard model we already always deploy when we have data just to get the numbers up. But it's also based on our experience, not the biggest value lever out there on the big OEM turbines. And I think a main reason is that though blades are related still with a lot of manual labor, quality has gone up quite significantly actually in the production of those blades. And then in addition, you typically supplement your commissioning with a balancing of 3 blades you put on a rotor. So fundamentally, after commissioning, you have a rather balanced rotor. So that's somehow some of the means that have been put in place to mitigate that issue on the longer run. But of course, somehow you will still have issues where blade failures. You repair a blade, right, with a different mass, and you can impose rotor imbalance. You might have extensive leading edge repair, putting on whatever, introducing weight differences again. So it can be certain elements in the lifetime of the turbine imposing new weight imbalances. And basically what we do is
think about that.
we pull out the G sensor accelerometer on the bed plate, and then we reverse engineer all the accelerations, and we kind of interpret which accelerations are coming from blade A, mass imbalance of how much, and then we provide the numbers on each tower and each blade. And then if you're within certain ranges, we recommend there's a standard operating procedure of how to balance blades, and it's physically that your technicians carry up ballast weights and mount them in a kilo. I think they are allowed to carry something like 15 kilos at a time. So we chop our analytics down to 15 kilos of pieces, and they carry up that ballast weight and mount it in certain places prepared for such in the blades. And then you can pull out data again and validate that you got the balanced.
Wow. Okay, that's fascinating. So part of that is driven by, obviously, if you put a new blade on to a turbine, because they had a blade repair or just a removal of a blade, a new blade put on, there's going to be that automatic imbalance. But also repairing blades can do that. I've seen blades that have been from the lightning side. You see a lot of lightning damage where there's been massive repairs done on site, and I don't know how they balance those blades. Obviously, they probably don't do a lot of analysis or measuring before the blade goes back into service. It is the repairs, and I'll give you a couple more examples, like the leading edge protection devices that are going on turbines now, the dyno tails that are going on the trailing edges. Do those change the dynamics of the blade enough that you can actually measure the G-forces, the accelerometers?
Yeah, it's actually all those well-meant and with a really good purpose retrofits that you deploy on the turbine throughout the lifetime. It all impacts the turbine performance, of course, both good and bad. So the repair work induces increased accelerations, and looking at the small differences allows us to tell how much. Sometimes it's not really big deals, other times it is. Mm-hmm. But of course, you don't really know before you look. I think that within that domain, the biggest thing we typically see is actually change of aerodynamical performance of the blades. So you basically want to do a power curve upgrade, gluing all kinds of stuff on the blades, as you mentioned.
Sure.
It serves a really nice purpose, and you get some additional power uplift. But the challenge just is that you only get half of the value that you could have had. because when you start to change the aerodynamical uplift of the blades, you need to adjust your controller curves in the controller. Otherwise, you're still running with the old controller set, so you only get half the
That's
value.
right.
So it's not on the asset integrity side, but significantly worth more than your orbit alignment correction.
Well, that's brilliant because it's not obvious, right? I think that's one of those places on the engineering side and from the asset owner side that is not necessarily obvious, because we see a lot of VG installations going on. We see a lot of larger blade repairs that are happening, and I don't think the owners are looking into what the can I therefore increase my performance of my turbines, or do I need to, or is it increasing the fatigue or decreasing the fatigue life of my turbine? We don't know. It's just a big unknown.
Yeah, just double your AP uplift, right? Because you will get an AP uplift from the retrofit and the upgrade, but you only get half of it because you're losing or you're leaving the other half with the old controller curves.
Wow. Okay, so there's a huge value in there for a service like yours to really maximize what is happening on the turbine itself. So if you're going to do a blade upgrade, what we call a power curve upgrade, that they just can't do that by itself. They need to be also looking at the control laws and also looking at maybe even watching the turbine for a 6-month period of time to see if there's any other issues that power curve upgrade has done to the turbine itself. It's not a one and done installation. There are consequences that you need to be monitoring. That is fascinating. Okay, I didn't realize.
Which is of course also a part of the industry, how it's structured, right? That every OEM selling off a PC or power curve upgrade kit, of course it's supplemented both by the physical work with rope guys gluing on the pieces, but also a software upgrade. Otherwise, they wouldn't get the control adjustment, as I mentioned. But the challenge is if any other third-party company is doing it, then it's only the physical work that is being done.
So that they may not be updating the controller to accommodate for the power curve upgrade that they made. So the VGs that went on may not be incorporated into the actual production of power. Yeah. Wow. Okay, that's fascinating.
And then wrapping back to the initial discussion, where does single pitch originate from, right? Yeah, but some of the single pitch cases we see is VGs flying off, because then you start to have one blade pulling differently than the two others.
Yeah.
So that's why the holistical top-down approach of not just solving that single item, but somehow understanding how the bits and pieces are connected. I think that's a key part of somehow getting some value out of that data part.
Well, from the asset owner's responsibility, and my line of work is probably very similar to yours, it doesn't make sense to have an analyst like you on site everywhere, right? So they're not going to hire an engineer to do your work at the facility full time. That doesn't make any sense. But it makes sense to tap into your knowledge base frequently. And that's where your business is. You're probably touching a lot of different sites simultaneously. That it's more economical to hire you and for you to do that analysis, being as the subject matter expert, versus hiring somebody to be on site full time that's a dedicated employee. Mm-hmm. Because most wind turbine asset owners do not have a large enough staff to incorporate someone like you. But you're a very critical piece in terms of power production and lifetime. You're talking about lifetime issues here.
Yeah, definitely.
Yeah.
But it's also based on the you could say the feedback and the understanding of that. The technicians, they have a core insight into their domain and what they can bring to the table. The back office guy or girl, right, have a core insight into their piece of the puzzle. And if we start putting on all the pieces on the table and start assembling that puzzle, then you would know where to get started.
So is part of your business a training knowledge business where you need to make the technicians aware of some of these different aspects they maybe not have thought of before, or that the asset owner may not have thought of before? Is part of your business just an education and bringing people aware of what is actually happening out there?
Yes and no. If I may rephrase it differently, I think as I really love my time in big corporations like Ørsted and Siemens, and they do fantastic things. And they're so bright people. But what they already have is a really large investment on tools, IT, skills, great people, and all that, right? And as a small company like ours, we also need to acknowledge that we cannot really conquer the world. It's an unbalanced game. So all the stuff we do in back office with the math and the analysis and stuff, that has been spun out into individual IT modules that we plug into the customer infrastructure so they can do it all themselves. So it's not like you can say an online training course we're conducting, but we acknowledge that we are not a company that will try to put in yet another IT platform with the right color buttons and all that stuff. It's more like we have some IT pieces, and if they want to do it themselves, that's fine, because we acknowledge that you have an infrastructure already, which we kind of guess and know, and then we put on our IT modules, and then they can do all the math themselves independently of us. And in that methodology, there's a certain element of training.
Well, yeah. So they're not going to rely on you forever. I think that's what you're saying, is that there's a training element, and you need to bring them up to speed, because obviously they do have their own IT infrastructure, and they do have capability on hand, but they just don't know where to look. And so that part of your business is to get them off of the training wheels sort of business into doing their own thing. But that can take several years. I know when I help aerospace companies on lightning protection, same thing on wind turbines, it's like a 3 to 4 year process before they can kind of do it on their own. And in that transition period, people like you are extremely invaluable, because you can get them to the answer faster. And that's where their profitability can increase, because you can get them where they couldn't have done it themselves. It would be much more expensive to do that themselves. And is that sort of where your sweet spot of your business is that you are that subject matter expert? You can bring in that knowledge, particularly if they're a relatively new owner and they're buying a relatively new turbine. I think you can bring a lot to the table in terms of just analytics to say, okay, let's watch how these new turbines perform, and then we can decide what we need to go do, if anything.
That's definitely one of the spots where we tap into, but I think the learning is also that it's also in rather mature, really large US corporations running really large portfolios, but where they have acknowledged that, and that's also my opinion, they do the math and the physics and the turbine understanding way better than we're doing, but we can provide speed and we can provide the solution tomorrow. So there's really no way of not buying into that opportunity. If they can sustain their independence and leverage their scalability in the business, why wouldn't they buy the nuggets instead of developing everything themselves?
Yeah, you guys are agile. You can just jump in there and get the job done. That makes sense.
And on the other hand, we are not of a size of a company that could take over their responsibility, right? So we're somehow playing into each other's strength rather than trying to do everything ourselves individually.
That seems like that's probably really important in your sales pitch to a big company, where it's like, look, we're not trying to replace or do your job. We can coexist really well, and we can fit your big company and just complement you guys.
Yeah.
So you know pretty much, based on the type of turbine that a site may have, what the list of issues typically are. So when you actually come to a potential client, you have a toolbox of knowledge that says these particular wind turbines have these kind of issues, and this is how we can help you mitigate them. I think that's very important if I'm an operator or a manager of a site, because a lot of times it's very hard to get that kind of information out of the OEMs. That it seems to come from third parties that track what's happening around the world to provide that information to the local wind turbine operator. So when you come in there, you're coming prepared, in a sense that you have identified, based on your knowledge, where some key issues are, and at that point, then you're listening to the wind turbine site owner explain what problems they're having and try to match the two together. Are a lot of the wind turbine sites seeing a lot of difficulty in terms of broken equipment, and is there a consistency there that you're seeing right now?
Yes and no. Of course, there are differences between brands, between platforms within brands, depending whether it's onshore, offshore. We work quite a lot offshore in Europe also. You get that to US also now. But end of the day, what drives the business case on the asset owner side, blades, gearboxes, drive generators, and all the big component stuff, that's the same, and it's been for the past 20 years. So it's not really that big a surprise always what we look at, starting top down. but the ways we have now in front of us with looking into different data streams and so forth has improved significantly throughout the last few years, right? So yeah. So I think it boils a bit back to that we are fundamentally an engineering company. We might spend our day looking into a screen with data and IT and math and physics, but we're an engineering company.
Sure. And data is really key to your analysis, right? That you need data. You need data to be able to process, to point out where those difficulties for that asset owner may be, in the sense of, if they don't have any data, it's very hard to help them. Obviously, if they have just broken equipment, or they have bearing failures or blade failures, those are pretty easy to diagnose at times. But I think you dive in a little bit deeper. You can actually take some of the data off the turbines, it sounds like, and then analyze that to say, these are where your key areas are. But I think, is there a lot of data from particularly some of the older turbines, say they're 10 years old? Is there a lot of data from those turbines besides just breakage and damage?
Yeah, at 10, if you ask me 15 years back, then the data streams are not that consistent, and the quality is not that good. But 10-year-old wind farms actually has a reasonably good data infrastructure. And what is data infrastructure? It was never anticipated to be a data infrastructure. It's like it's a PLC that runs a turbine. It's an industrial PC operating a control system. It's like whatever you have on your laptop. It was never anticipated to generate a data pool, but now it's there. Why don't we just pull it out and use that as a baseline for the assessment? That's what the OEMs are doing to balance the inner warranty discussions, to know the pricing of the service contract and so forth, right? Yes, correctly, the data is there, and a part of the assessments we do is based on that data we pull off those turbines. But I must also be honest to say that a lot of the assessments we do is based on the data that the customers already have in their hands. And if they look with in certain dimensions, then they would see also what that data resembles on operational performance.
Sure, they just don't have the experience to put the right perspective on the data, and I think that's really important, because when you start talking about data analysis at this level, you're looking at very, very relatively small differences and variations across turbine to turbine that may add up to losses of thousands, tens of thousands, hundreds of thousands of dollars over time, and so you're able to pick out that little bit of variation. I think that's really important here. It's you're picking out, based on your knowledge and based on your ability and your engineering ability, you're able to pick out where those variations are and what they mean. Because sometimes the data is not very clear, right? So it takes a little bit of experience to put that. So even the asset owner may not be able to discern what this variability means. That's where they're coming to you, right? They may see the variability, but they can't interpret it. And what part of the turbine do I need to address? You connect those dots, right? Isn't that kind of how your business works? That you're connecting the data with the real world equipment.
Yeah, that's a good way of seeing it. But I think it's also to demystify it a bit. I think actually before we connect the dots, we pinpoint what is the question we will try to answer. Yes. So it's actually it doesn't have. I know some of the models we're running is not right rocket science, but it's somehow sophisticated engineering models. But we also have solutions based on standard 10 minutes data that tells you the gear oil differential pressure. So why would you go to a turbine do angular service on a filter that is not really contaminated? Right. It's subtraction of two numbers. It's really not finding standard deviations of small sizes. It's just, what is the question? If the question is pressure drop across the inline filter, but then it's just subtracting two numbers. Right. But it starts with a question.
Right, exactly. But I think when you add on the engineering part of it, I think that's where the magic occurs. Obviously, to engineers, I'll phrase it this way. To engineers, sometimes the black magic isn't so black and it's not so magic. It seems relatively straightforward because you've been in that industry for such a long time. It seems somewhat obvious to you, but it's not obvious to a lot of other people. And I think that's
I
where
agree.
your value lies, is that because you have a very specific skill set, which is extremely valuable to a lot of operators and asset owners, that you can diagnose. You're like a physician. You're like the doctor. You're the physician. I have this pain in my side. How do I get rid of it? Or I may not even know that I have it, right? I may have it like a growth that I don't know I have, right? Exactly. So I need to get rid of it.
But that's actually a good image, right? That's also why whenever someone asks me about your misalignment, we can find your misalignment. But it's like the old man going to the doctor, having been running for his entire life. I'm always a bit of a hurt in my feet, but I have other issues that are more important. Right. So why would I start with the small stuff? There's so much value elsewhere.
Talk. So obviously you've been in the wind industry for a long time. You've seen a lot of changes in the industry. And as we start to move towards the end of the conversation, I want to get your take on jobs, on young people who are interested in entering the wind energy industry. So first, how have you seen things change over the course of your career? And then in a couple of minutes, I'm probably going to ask you, what some general advice would be for young people who are looking to get their feet wet and get started and make a name for themselves in wind energy.
It's actually a really difficult question, I think. There's so many things playing into it, and also the context that the context and the career you want to pursue within the wind turbine industry, right? Because there's so much business to be done. There's so much new technology coming in. There's so much existing technology to be maintained. There's so many different skill sets that are actually needed. So it's kind of hard generalizing.
Well, let me ask you a targeted question then. As a boss of a small company, what are some of the skills that you really value in a new employee? And what should young people, and not necessarily just young people, but again, people who are looking to make a splash in the industry, what skills should they be trying to cultivate? Are there new skills driven by data and new technology that they need to be staying current with?
Yeah, I think if we just look at ourselves and somehow to get on board, you need to be a reasonably good engineer, just as you needed to be 20 years ago. You need to know your math and physics. You need to know, you need to have strong side in mechanics or electricals, a strong side that is supplemented by also understanding the context. And that's like core fundamentals. And they haven't really changed. Of course, what has changed a bit is that whatever you specialize within that engineering field, it is more and more driven by data, right? So you need to have kind of flair for doing some kind of analysis. You don't need to be a core data scientist, and you for sure, certainly not, does not need to know anything about neural networks. You need to know your math, and that's it. And then around the engineering piece you're looking at. And then you would have other capabilities on the IT side or business IT supporting how to structure terabytes of data, how to get the flow up and running so you are removing inefficiencies and you don't sit with the Excel sheet doing whatever, but it's in a pipeline and you can do your analytics in a modern way. So I think the two main skill sets is on the core engineering, supplemented by the flavor of looking into IT, and the core IT with the flavor of looking into what is actually the need from my engineering colleagues. So in that way, it sounds rather generic, but that's basically how it comes. Mm-hmm. And then I think we talked about it the other day in preparation for this in office, and then you need to have some fun in your spare time. A lot of the people working with us, they play music in their spare time. Yeah. And I don't know why, but that has turned out to be a good indicator. I don't know if that's generic, but at least it somehow it's not really rocket science, but you need to do your stuff well, the fundamentals.
Well, it sounds like you value employees who have an overall life balance. It sounds like you want employees who have a life outside their job, and that's maybe making them more productive when they do come to work.
Yeah, definitely. Or a lot of the time, my co-founder Tommy and I will take a run during the week before lunch. Some of the best how to filter a certain element of data to remove noise or whatever. That's during the runs. It's not by sitting looking at a screen.
It's by getting out there.
But of course, having said that, you don't get the ideas by only running, right, or by only doing other stuff. You need to put in the hard work.
Right.
Otherwise, you don't really create the questions you will solve when your brain get a bit of freedom.
Right. That's right. That's exactly how it works. It's very odd to hear somebody else say it, but it's exactly how it works. It's like you have to put in the hard work, and sometimes the answers do not appear when you're doing the hard work. The answers appear when you're not thinking about it. Like your brain has a little bit of time to relax and to stretch possibilities. That's when the ideas pop out, and I think you're right. It does take a certain subset of people to think that way. It's not. There's nothing you can necessarily pinpoint on a resume to say this person can do that, maybe besides just experience, but having a little more well-rounded personality, and I think in wind turbines that's really true, that having a little more well-rounded of a personality and being willing to adapt to different situations is really beneficial in wind. It really is. Yeah. Fascinating.
Well, and I imagine with COVID, there's a lot more communications skills that people need to have, because you're not going to have those face-to-face, right, meetings. You're not going to have those business lunches and those dinners where it's a lot easier to break the ice and get to know people. Has it been a challenge for you trying to get your message across and meet with new potential clients, because of COVID? And has the skill set as far as communications changed significantly?
I don't know if it's changed, but it's a really good point, and that's one of the, you can say, capabilities that are really difficult to both maintain, but also just building from scratch, right? You learn so much by talking to different customers throughout US, comparing that to what are the questions we're getting from Philippines or whatever, understanding the bigger context and getting all the feedback from the end customer. It's a frustration thing, right? But it's a fantastic learning curve. And of course, with the COVID stuff, and we cannot go to the customers on site and actually, really see stuff and take that learning. And it's like getting that insight. So of course, there's some limitations in that. But on the other hand, as I said before, I think the number of live meetings has gone up quite significantly. So we still get a lot of really good feedback and guidance from the people who know better about real life problems, which we try to find in data afterwards. Mm-hmm. And that's the real training camp, right? Somehow building up that experience base for each of us, and also making sure that, well, now you mentioned the new GE turbine, right? Which I haven't seen from the inside yet, but a lot of the other new brands coming out, of course, they change, and we need to also stay on the beat of what is the new within the control stuff, so we can look for opportunities within that space.
So, Michael, you bring a lot of capability to the table, and your knowledge base is really extensive. What is that value proposition that you're making to your potential customers? How are you approaching them, and how can you help them in the short term, and then also in the longer term?
The first value proposition we bring to the table whenever we engage with a new customer is be specific. Start with the site. And then we basically assess the entire performance of that site, and we squeeze everything out of it that is left on the table, whether it's within Park Electricals, single turbine underperformance, or whatever we find in that process, together with the internal key people on the domain side. That's always the first step, and also somehow building some trust and getting to know each other from the collaboration side. Mm-hmm. The steps forward has taken different paths. For some clients, we end up doing the entire portfolio they're having, so more on the fleet level, where we roll it out. And for other clients, they insource some of our solutions and capabilities for the internal organization to leverage the scale they have.
Sure. And then how that plays out over time, because I know you like building long-term relationships. How are those progressed over time? Is it that they're relying on you as just to bounce off ideas, to bounce off concepts, or is it still a lot of data analytics as you go 3, 4, 5 years into a customer's experience?
No, we have some rather long customer experiences, both in Europe and in offshore, North America also, which are highly appreciated. That's also where we have a lot of feedback. So of course, everyone within this domain are on a journey. And I think us as a multi-brand engineering company, we see a lot of things on our way. So there's continuously relevant topics from a value point of view to discuss with our long-term relationships. So we haven't seen that they somehow die out. There's always new analytics, new value pools to be implemented or explored mutually.
Yeah, that's just brilliant. I agree with you. I think as turbines age and as sites age differently and have different types of issues, that it's hard to correlate that information, and you can be that key resource to bring new information to the table so that the next site doesn't have those issues. I think that's brilliant.
Well, Michael, we really appreciate you coming on the show today, and this was a really interesting conversation and very wide-ranging as well. And I especially appreciate the glimpse into how you started your company, because I think a lot of people out there who are in your shoes, very experienced as an employee of a big company, they struggle to take that first step. And I think it's a really it's an exciting time, and it's a scary thing, and it's cool to see how your business has evolved since then and how you coexist with these big companies now. So it seems like you have found your niche and really fit in there well. So for those of you out there, you can follow up with his company, Anemo Analytics, at anemo-analytics.com, and you can also follow them on LinkedIn. So definitely be sure to check out his company's website. And Michael, thank you so much for coming on the show. We really appreciate it.
Yeah, and thanks a lot for the opportunity and the discussion with both of you. It's really interesting.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install Strike Tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions, and we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.